Hello everyone and welcome to STEM School. Now in today's video we'll be looking at calculating the gradient of a straight line, and this is the first video of the straight line topic and we'll go through some exam questions. So before I begin, please do remember to hit the like button and consider subscribing to the channel. I'll greatly appreciate that. Alright, so let's get started. So what do I actually mean by the gradient of a line? Well, the gradient is essentially the steepness of a line. You know, you can have a fairly steep hill or you can have a really steep hill. So if you think about it like that, it's just the steepness. Now, there's some theory that you need to know for this topic, okay? Now, the steeper the line, the bigger the number, okay? So here we've got an XY graph. This is what you'll see a lot when it comes to the straight line topic. So say if we had a line like this. So we can have the gradient, which we call m. So m is equal to 3. Now what if we had m is equal to a smaller number, m is equal to a half? Well, what it will be a less steep line. Okay, so m is equal to a half. Okay, so the steeper the line, the bigger the number. Okay, so what you want to think about it is that m, the gradient, is equal to the vertical over horizontal. So if you look at this one here, m is equal to a half. What we're saying is that we're going across 2 units and up 1 unit, okay? Whereas in this one, the gradient m is equal to 3, this is the same way as writing 3 over 1. So vertical over horizontal, so it'll be across 1 unit but up 3 units, okay? So this one is steeper, bigger number, and then this one's a less steeper, is a smaller number, okay? Okay, so the next point is that if the gradient is positive, then the line slopes upwards, okay? So we can have a line like this, okay? So this is when we can have a gradient, you know, m is equal to 4. We have a positive number, so the line is sloping upwards, okay? Alternatively, if the gradient is negative, then the line slopes downwards, okay? So we can have something like this. So m is equal to a negative number, say -6, okay? A really steep decline, okay? Okay, so the next point is that and that parallel lines have the exact same gradient, okay? So say if we had a line here, so m is equal to 2, for example, is a positive number, so that means the line is sloping upwards. But say if we had another line as parallel, so this parallel line has the exact same gradient, okay? M is equal to 2, okay? Now, lastly, what I want to mention is that when you have a horizontal line, then the gradient is 0, okay? So say if we had a horizontal line, well, m, the gradient, is equal to 0. Then if we have a vertical line, then the gradient is actually undefined, okay? So say if we had a vertical line like this, well, the gradient m is undefined, okay? Undefined. Okay, so that's all the theory that you need to know for this section. Alright, so how do we actually calculate the gradient of a straight line then? Well, if you're asked to calculate the gradient of a straight line, what you need to know is 2 points on that line, okay? And once you know 2 points on that line, then we can use this magic formula, okay? So this is m, which is the gradient. So m is equal to y2 minus y1 all over x2 minus x1. So this is the formula you need to remember, right? But what is y2, y1 and x2 and x1? Okay, well, you're given 2 points on a line, right? So x1 and y1 is the x and y coordinate of the first point, and then x2 and y2 is the x and y coordinate of the second point, okay? Now, there are a variety of different questions you could get regarding, you know, calculating the gradient. The simplest case is when you have literally just been given 2 points and you're asked to calculate the gradient. So you've been given the 2 points, so you don't need to do anything else, right? Now, the slightly harder case is when you're shown a graph of a straight line and you need to identify 2 points on that straight line yourself. So it's slightly harder, but it's the same process of using this formula, okay? So we're going to quickly do the first case where we're literally just told the 2 points on a straight line. So for example, we could have the coordinate 6, 6 and 12, 10, okay? So we're told that these 2 points lie on a straight line and we've been asked to calculate the gradient. So anytime you're asked to calculate the gradient, just write this formula down immediately, okay? So y2 minus y1 all over x2 minus x1. Okay, so you've done the good bit of remembering the formula. Now, what do we have to substitute? Well, I recommend you just write the coordinates down and then label it so there's no confusion, okay? So this will be x1, this will be y1, and this will be x2, and this will be y2, okay? So once we've labelled it, let's just substitute them in. So y2 is 10, and then y1 is 6, okay? Now let's do the denominator. So we have x2 is 12, and then x1 is 6, okay? So all we have to do is just calculate it. So 10 take away 6 will be 4, and 12 take away 6 is 6. Can we simplify that? Well, yes we can. This will come down to m is equal to 2/3, okay? So that's our final answer. So if you think about it like the staircase, right? So m is equal to vertical over horizontal. What this is saying is I'm going to go across 3 units and I'm going to go up 2 units, okay? So just think about it like a staircase, right? Now let's have another quick example. Let's do, if we given 2 coordinates, we have -4, 7, and then we have 2, -5. Okay, so similar to before, we've been given 2 coordinates. We're told that these are on a straight line. We've been asked to calculate the gradient. Okay, so the equation for calculating the gradient is y2 minus y1 all over x2 minus x1. Okay, now let's label the coordinates so we don't make a mistake. Well, this will be x1, y1, this will be x2 and y2. Okay, doc, so let's just substitute that in. So we have -5 take away 7. So y2 is -5 and y1 is 7. Okay, now x2 is 2 and x1 is -4. So it'll be -4. Okay, so just put it in brackets if you have a double negative, just so you don't make a silly mistake, okay? So -5 take away 7, that will be -12. Then 2 plus 4, so double negative, it will become a plus, so 2 plus 4 is 6. So this will give us a final answer of m is equal to -2 as our gradient, okay? So what does that mean? So m is equal to vertical over horizontal. So if we have a gradient of -2, okay, this is the same as writing -2 over 1, okay, as a top-heavy fraction. So if you think about it, we're going to go across 1 unit, but we're going to go down 2 units, okay? So what we have is a downward slope, okay, because we have a negative gradient. And then the first example was a positive gradient of 2/3, okay? Okay, so let's just dive into the first exam question then. So this question is saying a straight line is drawn on the centimeter grid. Okay, so here's the diagram here. We have a straight line on an XY graph as you'll typically see, okay? Now, Faye assumes the scale is 1 centimeter per 1 unit, and we have to use her assumption to work out the gradient of the line. So this is just saying that per box it's 1 centimeter, okay? So you can just quickly, because the diagram itself doesn't have the scale written on it, so we can just quickly write the scale. So it'll be 6, 7, and this is in centimeters. And then same with the y-axis, so it'll be 1, 2, 3, 4, 5, 6, and 7, and that's in centimeters, okay? So you've been asked to calculate the gradient. Anytime you've been asked that, just quickly write the formula down, okay? So to calculate the gradient is y2 minus y1 all over x2 minus x1, okay? So anytime you need to calculate the gradient, you need to know 2 coordinates on that straight line, okay? So we've been given the straight line on a graph, okay? So we have to identify the 2 coordinates ourselves. So let's pick an easy point where the line crosses a diagonal box, okay? So what I can do is use this one. So that's a nice point to choose. So this is 4, 4. Just look at the scale that you've written. And now let's pick another point. Well, I can literally pick, that point there. I can pick this point here. But I'm going to pick this point as well when it crosses the y-axis. In other words, that's the y-intercept. So this coordinate is 0, 2, okay? So we know 2 coordinates, and now we can actually calculate the gradient, okay? So what is the 2 coordinates? We have 0, 2, and then we have 4, 4, okay? Now let's label it as before, so x1, y1, then x2, y2, okay? So now we know what we can substitute into this formula to calculate the gradient, okay? So y2 is 4, y1 is 2, 4 take away 2, then the denominator, so x2 is 4, and then x1 is 0, okay? So let's calculate that. So 4 take away 2 is 2, and 4 take away 0 is 4, okay? So what does that give us? So if we can simplify this fraction down to m is equal to a half, okay? So that was quite simple. All we have to remember is just look at the straight line graph and identify the two coordinates ourselves, okay? Then label the coordinates so you know what to substitute into that formula, okay? So this is a positive gradient, so it's an upward slope. What we're saying is that we're going to go across 2 units and up 1 unit, okay? So that's the final answer there. Alright, so let's have a go at this last exam question then. So we're told that the coordinates a02 and b65 are points on the straight line ABCD. So we're told this statement that AB is equal to BC is equal to CD. What that is saying is that the length of AB is equal to the length of BC, which is also equal to the length of CD, okay? So we have this diagram here with points A, B, C, D. So this is just showing that the points are equally spaced from each other, okay? So what we have to do is work out the coordinates of D. So when you actually look at this question, it hasn't told us to work out the gradient specifically. That's the problem solving aspect, okay? So what we have here is a straight line on a graph, and we have two coordinates. When we see that, you should immediately think, well, I can calculate the gradient here. And then once you calculate the gradient, you can use this idea of the staircase to then manually work out each coordinate on this straight line until you get to point D. So that's a very useful technique when it comes to straight line equations and straight lines on graphs, etc. Okay. So let's first of all calculate the gradient of the straight line. So this is a formula, y2 take away y1 all over x2 take away x1. We can use this formula because we know two coordinates, which is A is 0, 2, and then B is 6, 5. Okay, now let's label it so we know what to substitute. So it'll be x1, y1, and then x2 and y2. Okay, so let's substitute these values into this formula. So y2 is 5 and y1 is 3, so 5 take away 2, and then x2 is 6 and x1 is 0. Okay, so let's calculate this. So 5 take away 2 is 3, and 6 take away 0 is 6. So what this simplifies down to is a gradient of m is equal to a half. Okay, so we have a positive gradient here, so that implies it's a positive slope, which makes sense given the diagram we've been given. Now, if we want to visualize this further, what we can say is that the gradient m is equal to vertical over horizontal. So what we're saying is that we're going to go across 2 and then plus 1. Okay, so across 2 and plus 1. Right. So we know the gradient, okay, m is equal to half. So what we can do here is this staircase idea. So this thing here, what we're going to do is start from A, manually go across 2 units and up 1 unit until we get to point D. Okay, so that's the easiest method that you'll easily recognize how to do this. So let's have a go at this, right? Let's draw this straight line. Okay, so what we're starting off with is A, which is 0.02, and then we have point B, which is 6, 5, okay, and then we have point C, and we know it's equally spaced, so C and D, okay? So like I said, we have been told that m is equal to a half, the gradient is a half, so we're going to go across 2, then up 1. Okay, so basically you're adding 2 to the x coordinate and then adding 1 to the y coordinate as you go along. Okay, so we start from A, 0, 2. Let's go across 2 units and up 1 unit. So what's the coordinate there? So it'll be 2, 3. Okay, so you add 2 to the x coordinate and add 1 to the y coordinate. So 2 plus 1 is 3. Okay, then you keep going. So across 2 plus 1, what's the coordinate there? It will be 4, 4. And then let's do it again. Okay, so across 2 plus 1, what do we get? So 4 plus 2 is 6, then 5 plus 1 is 4 plus 1 is 5, okay? So how do we know we've actually done this right? Well, we've gotten the coordinate 6, 5, and that's the exact same as the point B that we've been given from the question, 6, 5. Okay, so we're on the right lines here. So let's keep going. So across 2 plus 1, what we have here is 6 plus 2 is 8, and 5 plus 1 is 6. Okay, then keep going across 2 plus 1, so that'll be 10, 7. And then we just do it again, okay? So then we get to C. Okay, so we know it's equally spaced, so you're going to do 3 steps, okay? Because it's equally spaced. So this will be 2 and then 8. Okay, so let's keep going. We have across 2 plus 1, so this one will be 14, 9. And then go across 2 plus 1, and this coordinate will be 16 and 10. And then the last step will be across 2 plus 1. So 16 plus 2 is 18, and then 10 plus 1 is 11. Okay, so this is the final answer for coordinate of D is 18, 11. Okay, so there we have it. So we know we've done this right. We've calculated the gradient of M is equal to a half, and then we started at A, 0, 2. We've done each step, and we actually reached a point B, which is calculated as 6, 5, which is the same coordinate given to us in the question. So this is how we know that we've gotten the right value for the coordinate of D. So just remember, this whole staircase method is a very useful technique when it comes to calculating different points on the straight line, okay? Okay everyone, so those are the different types of exam questions you could get when it comes to calculating the gradient of a straight line. Now please do remember to hit the like button and consider subscribing to the channel, and I'll see you in my next video where I'll be carrying on with the straight line topic with further types of questions, so I'll see you guys then.